Dear all, welcome to another sessions of Woutens Edu. In this session, we are going to discuss about the basic concept of definite integrals. Followed by it, we will discuss two properties of definite integrals. Based on that two property, we will discuss some interesting problems. Once again, welcome to Woutens Edu. In calculus, we have studied about functions, limits, differentiation, differential equations, integrations, and now come its definite integration. What is definite integration? Basically, if we have function, everything we are starting with function. Suppose f of x be a function that is defined in open interval ab. We have function f of x. This is our function, and this function is defined in an open interval ab. That is, this function is defined in open interval AB, and the next condition is the function should be continuous in the closed interval AB. That is, this function is continuous, a continuous function. What is the interval? In closed interval AB. That is, continuous in closed interval AB, and the function is also differentiable and interval is open interval AB. That is, this function is also differentiable in open interval AB. That is, the function is differentiable in open interval AB. So we can write dy by dx of this function f of x is equal to some g of x. Then, if this function satisfies these three conditions, these conditions are called the fundamental principle of integration or first principle of integration. And dy by dx of f of x is equal to g of x. Then we can write integral g of x dx is equal to f of x plus c, where c is a constant of integration. Now we are evaluating this integration with respect to limits. Let the lower limits be a and upper limits be b. That is, a and b is an open interval. So this is equal to apply the limits a and b. So we get f of b plus c. That is, I applied the upper limit. Now apply the lower limit. So this is equal to this minus f of a plus c. Here it is a plus c minus c. So that will cancel. So plus v, c and minus c get cancelled. So the remaining term become f of b minus f of a. Value of this definite integral in between the interval a and b. That is f of b minus f of a. Now, based on this property, we are going to do some problems. After that, I already told I will discuss two properties. Only two properties. Based on that two properties, we will do some interesting problems. Okay? Let us start. Okay, look at this problem. We have an integration. The lower limit is 0 and upper limit is 1. That is, x dx divided by x square plus 1 the whole square. And the options are given 1 by 2, 1, 1 by 3 and 1 by 4. Now we want to evaluate the value of this integration. Now we have only one definition. We are not yet discussed the many properties. Okay, let us do this problem. For this problem, in the numerator we have an x. In the denominator we have x square plus 1. So we simply putting this x square plus 1 is equal to some other variable. Let it be t. That is, x square plus 1 is equal to t. Now differentiate LHS and RHS. We will get 2x dx is equal to dt. So this x dx can be replaced by dt in the numerator. So x dx is equal to dt by 2. Right. Now apply the limit. When x is equal to 0, what is the value of t? T is equal to 0 square plus 1, that is equal to 1. That is, when x is equal to 0, t is equal to 0 square plus 1, that is equal to 1. Now, x is equal to 1. What's the value of t? T is equal to 1 square plus 1, that is equal to 2. So, we change the limit of integration. Now, we can write this integration as integral 1 to 2 x dx is equal to dt by 2. I am taking this 2 outside of the integration since that is a constant. Dt divided by x square plus 1 become t square. Okay, now this is our integration. T raised to minus 2 plus 1 divided by minus 2 plus 1. Apply the limit 1 to 2. So this is equal to minus, here we have a 1 by 2 already in the outside of the integration. That is the constants I just put here. Now this become minus 1 by t. Limit 1 to. This minus can be taken outside. So this is equal to 1 by 2 integral 1 by 2 minus 1 by 1. So this is equal to 1 by 2 minus 1 by 2. Here it is a minus, right, minus. So this is equal to 1 by 4. So our answer is option number D. This is our answer. Right, so value of this definite integral is a constant that is equal to 1 by 4. Now consider our second question. We have an integration. That's a definite integration. The limits of integration is from 1 by pi to 2 by pi. And the function is sine 1 by x divided by 1 by x square dx. And options are given 1 by 2, minus 1 and 1 by 4. Let us do this problem. Now consider the denominator 1 by x square, right, and numerator sine of 1 by x. Now we know that the differentiation of 1 by x is minus 1 by x square. So we can put 1 by x is equal to another variable, that is t. So let 1 by x is equal to t. Now differentiate LHS and RHS. We will get minus 1 by x square dx. This is equal to dt. So we can replace dx divided by 1 by x square by minus dt. Now the next step is we have to change the limits of integration. That means when x is equal to 1 by pi, what is the value of t? When x is equal to 1 by pi, that implies t is equal to 1 divided by x, that is 1 divided by 1 by pi, that is equal to pi. Now what is the upper limit? Upper limit in terms of x is 2 by pi. That means x is equal to 2 by pi. What is the value of t? T is equal to 1 divided by x. X is 2 by pi. So this is reduced to pi by 2. Okay, pi by 2. Now we can write this integration in terms of t. That is integral lower limit is pi and upper limit is pi by 2. Sine 1 by x, that is replaced by sine t divided by, this entire term is replaced by minus dt. So integration of sine t with respect to dt. This minus is taken outside. So this is equal to integral sine t. What is integration of sine t with respect to t? That is minus cos t. So minus of minus cos t. And the limit of integration pi to pi by 2. Minus and minus become plus. So this is equal to plus cos t. Limit of integration is pi to pi by 2. That implies cos pi by 2 minus cos pi. Cos pi by 2 is equal to 0 minus cos pi. Cos pi is minus 1. This minus 1. Minus of minus 1. That is equal to 1. So the correct answer is option A. Our question is integral 0 to 1 square root of e raised to x divided by square root of e raised to x plus e raised to minus x dx is equal to, answer is given, log of e plus a divided by 1 plus root 2. So we want to find what is the value of a, and choices are given: e square plus 1, square root of e square plus 1, e square and e square minus 1. Okay, how can we crack this problem? Let us see. Now, square root of e raised to x in the numerator and square root of e raised to x and e raised to minus x in the denominator. So it is better to convert either in terms of e raised to minus x or in terms of e raised to x. Let us convert it in terms of e raised to x. So I can write this as integral 0 to 1. Divide the numerator and denominator by e raised to minus x. Okay. Now I am dividing the denominator by e raised to minus x. So this term becomes e raised to x divided by e raised to minus x. That is e raised to x divided by e raised to minus x plus e raised to minus x divided by e raised to minus x. The numerator also by e raised to x. So this becomes 0 to 1. This becomes e raised to x into e raised to x. That is e raised to x square. E raised to root of e raised to x square. That is equal to e raised to x divided by, this term become e raised to 2x plus 1 with respect to dx. Now we want to change the variable of integration. Let put e raised to x is equal to t. Now differentiate. We get e raised to x dx, that is equal to dt. So this term in the numerator can be replaced by dt. And this term becomes square root of t square plus 1. So I can write this is equal to integration e raised to x dx means dt divided by square root of t square plus 1. Now what is the limit of integration? When x is equal to 0, that implies t is equal to e raised to 0, that is equal to 1. When x is equal to 1, t is equal to e raised to 1. So the limit of integration becomes 0. Instead of 0, we are putting 1. Instead of 1, we are putting e. So this is our required integration. Now, this is a standard integration. And value of this integration is ln of mod t plus square root of t square plus 1. This is the value of integral dt by root of t square plus 1. Now apply the limit of integration, that is from 1 to e. So this expression we can write as ln t, upper limit, t instead of t, e plus square root of e square plus 1 minus ln 1 plus square root of 1 square, that is 1 plus 1. Square root of 1 plus 1 is 2. So this is in the form log a minus log b. So this is equal to ln e plus square root of e square plus 1 divided by, this is ln e plus a divided by 1 plus root 2. This is the question. Okay, right. Correct this. So this is equal to this divided by 1 plus root 2. This is modulus. So comparing these two expression, this is e plus a. So is a is root of e square plus 1. So a is square root of e square plus 1. So b is our correct option. So in the starting we have said we will discuss two properties, and based on that properties we will do some interesting problems. Okay, these are the two properties, two simple properties. So integral a to b f of x ds is equal to minus of what I did here. I just changed the lower limits and upper limits. So lower limit is b and upper limit is a, f of x dx. This is our first property. And second property is integral 0 to a f of x dx is equal to integral 0 to a f of a minus x dx. These are very important two properties. Let us prove it. Let integral a to b f of x dx is equal to g of x. Now apply the limits of integration, that is a to b. What is the value of this? By applying the limit, we get this is equal to g of b minus g of a. Now we can write this as, take the minus outside. So this becomes minus of g of a minus g of b. So the equation is balanced. Now what is g of a minus g of b? That we can write, this is minus of integral, lower limit is b and upper limit a of f of x dx. This is same as RHS, hence proved. Now let us prove this. Integral 0 to a f of x dx is equal to 0 to a f of a minus x dx. Now let us consider our RHS. Our RHS is integral 0 to a f of a minus x dx. Now let's put a minus x is equal to some other variable t. That means a minus x is equal to t. Put. Okay. Now differentiate both sides of this equation. This becomes a is a constant. So the dv by df of a constant is 0. Minus dx is equal to dt. So dx can be replaced by minus dt. Now change the limits of integration. That means when x is equal to 0, what is t? T is equal to a minus 0. That is equal to a. When x is equal to a, t is equal to a minus a. That is equal to 0. So this integration become integral, lower limit become a, upper limit becomes 0, f of a minus x, that is replaced by t, f of t, and dx is replaced by minus dt. So into dt, minus is taken outside. So this is equal to, using the first property, this is equal to integral 0 to a f of t dt. Now change the variable t to x. We can change the variable. That is equal to integral 0 to a f of x dx. So this is equal to LHS. Hence proved. So we have another property. Integral a to b f of x dx is same as integral a to b f of t dt is equal to integral a to b f of u du. That is, changing the variable does not affect the values of integration. We use that property here to change the variable t to x. So this is the second proof. We can generalize the second equation. Instead of the lower limit 0, I am putting the lower limit is equal to a and upper limit is equal to b. So this implies integral a to b f of x dx. This is equal to integral a to b f of a plus b minus x dx. This is a generalization of this equation. This can be also proved in the same manner we proved the previous property. That is the same manner we proved this property. Okay. Now this property we can also write as, this is equal to integral 0 to a by 2 f of x dx. Now the upper limit become a by 2. This plus integral 0 to a by 2 f of a minus x dx. This is also a property. That means integral 0 to a f of x dx is equal to integral 0 to a f of a minus x dx. That is equal to integral 0 to a by 2 f of x dx plus 0 to a by 2 f of a minus x dx. Suppose f of x, this term f of x is equal to minus of f of a minus x. Then what happens? This become, we can replace this by minus of integral 0 to a by 2 f of x dx. This plus this, that become 0. So in particular, this is equal to 0 if, what is the condition? F of x is equal to minus of f of a minus x. If this is equal, then value of this integration becomes 0. Now, if f of x is equal to f of a minus x, if these two are equal, then this becomes 0 to a by 2 f of x dx plus 0 to a by 2 f of a minus x is replaced by fx. So 0 to a by 2 f of x dx. That becomes 2 times integral 0 to a by 2 f of x dx. So this is equal to 2 times integral 0 to a by 2 f of x dx, provided if f of x is equal to f of a minus x. So this property and the previous property, that is limit from a to b, that we derived from the second properties. So these two properties are very useful properties. So we should keep in mind. That means integral 0 to a f of x dx, that is equal to 2 times integral 0 to a by 2 f of x dx if f of x is equal to f of a minus x. Look at our question. Our question is integral 0 to pi by 2 1 divided by 1 plus cot x dx is equal to pi by 2, pi by 4 and pi by 3. So what is the value? So we can use properties. We have only two properties we have studied till. We can write this I is equal to integral 0 to pi by 2 1 divided by 1 plus, I can write cot x as cos x divided by sin x dx. This is equal to integral 0 to pi by 2. Take the LCM. So this becomes sin x divided by sin x plus cos x dx. Okay. 0 to a f of x dx is equal to integral 0 to a f of a minus x dx. Now let us apply that property. So I am writing I is equal to integral 0 to pi by 2 sine of a is pi by 2 minus x divided by sine of pi by 2 minus x plus cos of pi by 2 minus x dx. Sin pi by 2 minus x is cos x and cos pi by 2 minus x is sin x. So we can write this is equal to 0 to pi by 2, this term become cos x, and the denominator, this term become cos x plus sin x. Okay, let this equation number 1, this be equation number 2. So 1 plus 2, equation 1 plus 2 implies LHS become I plus I, that is equal to 2I, that is 2I is equal to integral 0 to pi by 2, here it is sin x plus cos x. The denominator of both functions are same, that is sin x plus cos x dx. The numerator and denominator get cancelled. So this implies 2i is equal to integral 0 to pi by 2 dx. That is equal to x. Apply the limit 0 to pi by 2. that is equal to pi by 2 minus 0 is equal to pi by 2. So 2i is equal to pi by 2. That implies I is equal to pi by 4. That is our answer. So option is C. Right. Now our question is I is equal to integral 0 to pi x dx divided by 4 cos square x plus 9 sin square x dx. And choices are given pi square by 12, pi square by 4, pi square by 6 and pi square by 3. Now again we are using our properties. That is, we can write I is equal to integral 0 to a f of a minus x. So this integration is equal to integral 0 to pi, x is replaced by pi minus x dx divided by 4 cos pi minus x, the square, okay, plus 9 times sin pi minus x, the square. Okay, now we can write what is cos pi minus x, that is equal to minus cos x, the whole square, that is equal to cos square x. So we can write this is equal to 0 to pi minus x with respect to x dx divided by 4 cos pi minus x is equal to minus cos x, that is minus cos x the whole square plus 9 times sin pi minus x is equal to sin x, that is sin x the whole square. This term become 4 cos square x. So this become minus cos x the whole square. That become 4 times cos square x. So the denominator of both this I, this is also I, are same. Now let's put this is equation number 1 and this is equation number 2. So 1 plus 2 implies, what is 1 plus 2? I plus I. LHS become 2 times I, that is equal to 2I. Integral 0 to pi, numerator become x plus pi minus x. X plus pi minus x divided by denominator is same for both expression. That is 4 cos square x plus 9 sin square x. This different integration with respect to dx. This x and x get cancelled. So we can write this is equal to integral 0 to pi divided by 4 cos square x plus 9 sin square x. Now we have property. Using this property, that is integral 0 to a f of x dx is equal to 2 times integral 0 to a by 2 f of x dx, provided, what is the condition? Condition is f of a minus x is equal to f of x, or f of x is equal to f of a minus x. Right, now our f of x is pi divided by cos square x plus 9 sin square x. Now, what is f of pi minus x? Here a is pi. That is equal to pi divided by 4 cos pi minus x, the square, plus 9 times sin pi minus x, the square. So this is equal to pi divided by 4 times cos pi minus x, that is equal to minus cos x. Minus cos x, the whole square is equal to cos square x plus 9 pi sin pi minus x, that is equal to sin x. So 9 sin square x. So this is equal to f of x. We can write this term as, by using this property, 2i, that is equal to integral 0 to pi by 2. 2 times, that is 2 into this integration into pi divided by 4 cos square x plus 9 sin square x. Okay, now I am dividing this expression by cos square x. So I can write this is equal to 2 times integral 0 to pi by 2 pi. This pi can be taken outside, so this becomes 2 pi. Then dividing by cos square x, so numerator become 6 square x divided by 4 into cos square x by cos square x, that is equal to 1, plus 9 tan square x. Okay, now this is equal to 2i. 1, 2 in LHS and RHS get cancelled. So this I is equal to pi into this integration. Now put tan x is equal to t. Tan x is equal to t. Now differentiate. This will become 6 square x dx, that is equal to dt. Okay. Now apply the limit of integration. When x is equal to 0, that implies t is equal to tan 0. Tan 0 is equal to 0. When x is equal to pi by 2, that implies t is equal to tan pi by 2. Tan pi by 2 is equal to infinity. T is equal to infinity. Now our limit becomes 0 to infinity. So this is equal to pi into limit of integration becomes 0 to infinity. 6 square dx is replaced by dt. So dt divided by 4 plus 9t square. Okay. Now to make into standard form, I am taking 9 outside. So I can write this is equal to pi into integral 0 to infinity dt by 4 by 9 plus t square. Here also 9. So as to balance the equation. This is the form. This is the form integral dt by a square plus t square. This is equal to 1 by a tan inverse t by a. Okay. So this is equal to pi by 9 into tan inverse equal to 3 by 2t whole divided by 2 by 3. 2 by 3, that is equal to pi by 1 3, this can cancel, pi by 6 into tan inverse 3t by 2 limit 0 to infinity, that is equal to pi by 6 tan inverse infinity. Tan inverse infinity is equal to pi by 2. So this is equal to pi by 6 into pi by 2. That is equal to pi square divided by 12. This is our answer. So option A is the right answer. Now we have 4 questions. For these 4 questions, answer is same. Okay. First question is square root of sin x divided by square root of sin x plus square root of cos x. The limit of integration is from 0 to pi by 2. The second question is also the limit of integration from 0 to pi by 2. Sin raised to 3 by 2x divided by sin raised to 3 by 2s plus cos raised to 3 by 2s. This is another question. Same limit of integration is same. Cos raised to nx divided by sin raised to nx plus cos raised to nx. Here 0 to pi by 2 cos raised to 1000x divided by sin raised to 1000s plus cos raised to 1000x. For any question, this is the general form of this, that is n be any real number. Then for all this answer is pi by 4. This is pi by 4. This is pi by 4. This is also pi by 4. By using the property f of integral 0 to a f of x dx is equal to 0 to a f of a minus x dx. So this is equal to I. We can write I is equal to integral 0 to pi by 2 cos pi by 2 minus x the whole raised to n divided by sin pi by 2 minus x the whole raised to n plus cos pi by 2 minus x the whole raised to n. And what is cos pi by 2 minus x is equal to sin x, and sin pi by 2 minus x is equal to cos x. So I will get this is equal to integral 0 to pi by 2 sin x all raised to n, that is sin raised to nx divided by this term become cos raised to nx plus sine raised to nx. Now I plus I, we get 2i, that is equal to 0 to pi by 2, this cos raised to nx plus sine raised to nx, that is cos raised to nx plus sine raised to nx. The denominator is cos raised to nx plus sine raised to nx dx. Okay, now what happens? This and this get cancelled. This is equal to 1. So this becomes 0 to pi by 2 dx. That is equal to x. The limit of integration becomes 0 to pi by 2. So this is equal to pi by 2 minus 0. That is equal to pi by 2. That is 2i is equal to pi by 2. So I is equal to pi by 4. So the answer for all this question is equal to pi by 4. Next session we will discuss some more properties, and based on that properties we will do so many interesting problems. Okay, thank you. Bye. Have a nice day.